Hi everyone, my name is Victoria Janes-Bassett and welcome to my individual reflection as part of the Entangled Festival. So I'm a researcher at Lancaster University working on the Ensemble project. My research looks at land-soil system changes, so how drivers such as climate, land use change and different land management practices impact our land-soil system. So I look at past change but also change into the future and understanding how we can manage our land in a sustainable way going forward. Some of the work I've been doing is using environmental models. So environmental models are computer-based process and numerical representations of our environmental system. And one of the models I've been using is a model of soil and plant biogeochemical cycling. So that's looking at carbon, nitrogen and phosphorus cycling and how different land use changes and management practices have impacted on the availability and storage of nutrients in our land soil system. So two of the threads of discovery that I'm going to talk about today are looking at the local scale, so when we've applied the model at site scales and some of the research questions that have come out of that, but also what we're able to do when we apply the model at a national scale. Some of the research questions we're going to answer by applying the model at a national scale, but also some of the uncertainties we have when we're applying a model like that. So first of all, at the site scale, when we first developed the model in this part of this research, it was originally a model that looked at carbon, nitrogen, phosphorus cycling in natural ecosystems, so things like forests and natural grasslands. And what we've done is expanded the model so that it can also simulate agricultural systems and simulate land use transitions from natural systems to agricultural and vice versa. And what we found, we applied the model at a range of long-term agricultural experimental sites. So these are sites across the UK and Northern Europe where they've applied different management practices, so different fertiliser regimes of nitrogen and phosphorus, whether they're mineral and manure-based, different crop types, so traditional crop types for sort of temperate ecosystems, such as wheat, cereals, legumes and oilseeds and root crops. And we can test the model both spatially and temporally across these plots. And what we find with this fairly rigorous testing of the model is that it largely works very well. But one of the research gaps we identified was that when in some of these experimental plots, they add just nitrogen rather than nitrogen and phosphorus. And that's maybe not traditionally done in an agricultural setting, but these are experimental settings, and so different practices are done to investigate what impacts they might have. And what we found is where there was lots of nitrogen added but no phosphorus, the model was simulating things very different to what we observed at the experimental sites. So for instance, at the experimental sites when they added nitrogen, just nitrogen, crop yields were lower than they were when they were adding nitrogen and phosphorus, but the crops were able to be sustained. But the model simulated an exhaustion of phosphorus because basically this nitrogen that's added stimulated lots of plant growth, and the model was simulating exhaustion of phosphorus in the soil system, and the crop yields declined dramatically, which we weren't observing in reality. So we hypothesized where this phosphorus might be coming from in reality, that the model is missing. And we looked at various different sources, such as the phosphorus in the underlying bedrock, atmospheric deposition, but none of these could really explain the magnitude of phosphorus that was missing. So some of the work we've been doing is capitalising on the available data that we have now, and looking at the potential role of something called phosphatase enzymes that can be secreted by both plants and the soil microbiome. And this can access organic phosphorus and transform it through mineralisation to make it into an inorganic form that plants can then uptake. So using this model at a site scale and pushing it to extreme conditions that we might not experience in a normal agricultural setting, but in an experimental setting, we've been able to identify a gap in our process understanding, which the model has highlighted. So one of the other threads of discovery that I wanted to talk about was when we apply the model at a national scale. So we've applied the model across the whole of the UK at a 5-kilometre grid scale, and we've looked at how terrestrial carbon storage, so carbon storage in both the soil and the plant biomass, changes over time. But one of the things, before we look at change over time, we look at, well, can the model predict what current carbon storage across the UK. And that's a really interesting question, because how well do we know current carbon storage across the UK? So I've just got 3 maps here. The one on the far right is the model output, but then we've got 2 different data products, which are national data products derived from different data sets, from point data, and those point data are extrapolated to the national scale in different ways. And whilst the spatial patterns are broadly similar, the magnitude of the soil carbon storage that we're seeing in these 2 data products is actually quite different. So some of the other work that we're doing is looking at how, if we use different data sets and different methods to extrapolate these the data points to national scale maps, how different are the answers that we get in terms of national scale carbon storage, so trying to understand how certain we are about the baseline that we're at currently. So thank you very much for that brief introduction to some of our research that we've been doing on Ensemble, and please feel free to get in touch if you'd like to know more.